All right, as far as maintenance, corrosion can be a big problem, right? Some of the issues we have with corroded water, or water that is corroded, is that usually it is very low on the pH scale, right? Which means what? Corroded tanks, corroded lines end up doing what? Leaking, developing holes, and when that happens, what happens to our pressure? It drops. And now we can find ourselves in the situation where we are below the 20 psi problem area. Now, possible contaminants can be drawn within. So corrosion is an issue. Not only is it an issue as it relates to pressure, but what about health issues? When we have dissimilar metals, because again, dissimilar metals can lead to corrosion, now we can also have health problems associated with the various metals. So for as much as possible, we want to prevent corrosion, whereas we're maintaining pressure in the system, maintaining our system, maintaining not only aesthetic, because corrosive water can also be discolored. So we're trying to maintain both potable as well as the aesthetic aspect of waters. Some of the things that cause corrosion, various types of minerals, metals, and even bacteria can lead to corrosive water. So how do we prevent corrosion? Or how do we hinder corrosion from happening?
We can elevate the pH and inject a corrosion inhibitor.
Okay, so we can stabilize the water. He said to elevate the pH. What am I going to use to elevate the pH? Caustic, soda ash, lime. Now all these things that you all are saying, keep in mind it has to be what? EPA, NSF, any of those things approved. You can't put it in if not. All right, so if I raise the pH, I can prevent corrosion from occurring. pH should be where on that pH scale? Anything above 7. 7 is neutral, below 7 is acidic. Okay, cool. So I can stabilize the water with water treatment. Is there another way to prevent corrosion? I got water treatment. Oh, I can use that electrochemical method that Jerry does. What is cathodic protection?
It's a small current that's delivered to the pipe to basically repel the corrosive effects of the water.
So what I'm doing is using, again, anodes, cathodes. Cool. I got a sacrificial metal that I'm going to put there, and that metal becomes corroded, right? But it's better that method than our metal than our water. So it's an electrochemical method of doing. What metals do we normally put in as a sacrificial lamb, so to speak? Zinc, huh? Did I hear zinc?
On the outside of somebody's
Zincs, okay. What else? Jerry, is there any other that you all use? Okay. But zinc is one that's widely used that works as. So I have cathodic protection. I have stabilization of the water. Is there anything else I can do to help prevent corrosion? Paint the tank. Good. Coatings. Things like that can be added. So that's another way that we can kind of prevent corrosion from happening, those protective coatings there. Yes, sir.
Check with the gas company. Sometimes you get into corrosion protection wars. They try to protect theirs, and they overcome yours, and your pipe becomes sacrificial to them.
To theirs, huh?
Or they become sacrificial to you. Usually it's only one spot, but that's all it takes to leak.
Okay. Now that's a new one on me. I didn't know that. I learned something. Talk with the gas company.
Make sure
Okay.
the base you put it on is not hot.
Mm-hmm. Yeah. Okay, good. All right, you got all three of them. Very good. How many of you all deal with the Baylis curve? This is on the treatment side, and I got these baffled looks. Yeah. Now, operators utilize this as a process control mechanism. What the Baylis curve is, if you know your pH, and you're probably testing pH, right? And your alkalinity. How many of you all do alkalinity? I know mainly it's surface water plants, but any groundwater systems running alkalinity from time to time? If I know my pH and alkalinity, then I can utilize this curve here to determine whether or not my water is corrosive or scale forming. For instance, with an alkalinity, let's say a pH of 7, but my alkalinity is about 250. Now I'm in the stable area, but as alkalinity goes up, now it becomes scale forming. If I have very low alkalinity at a 7 and my alkalinity is under 150, my water will be very corrosive. So this can be, again, process control, one of the first things that I can utilize in order to determine if my water is scale forming or corrosive. Oh, good question. She's Lisa. Lisa asked, what's the difference between this and the Langmuir's index? About 4 different other lab tests you have to run. Okay. Very good question. With the Langmuir index, I need to know pH, I need to know the total dissolved solids in the water, I need to know temperature, alkalinity. There's another one. Calcium carbonate or something like that. So I have to run those other lab tests, and once I run those lab tests, the results I get, I put it into a formula, and once I put it into that formula, it'll give me a number. Based on that number, now it'll be whether or not it's scale forming or whether it's corrosive. Now the Langmuir index is much, 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 much more on the spot. If I want to be on the money, I'm going to go with that. This one here just gets me in the ballpark of what it is. So if I want a more in-depth test, I'm going to go that way. There's another test that's out there that you can look at also, not as extensive as the Langmuir's, but can be used as to determine scale forming. Good question. Yeah, but if you have the capability of doing all those other tests, that would be excellent to do. And if you have a lab, they're probably doing them all anyway. This one is just real simple. The average Joe Blow, Sally Sue can do without any, much additional stuff. Good question. All right, now, because we have ground storage tanks, and because from time to time you may have to enter to do the inspections and things like that, that word up there in the red is confined space. Do you see this as a confined space?
Yes.
And I heard no, and I heard yes. All right, Jason, why no? It's real big. You're absolutely right. It is real big. Question: is there limited entry and exits? Yes. Is there a possibility of a dangerous gas or toxic atmosphere? Yes. Is it designed where we can stay in there for at least 8 hours or so, or continuous occupancy? No. So is it a confined space? Absolutely. Those are the criteria there. And because it is a confined space, when entering it, you want to make sure that you are being safe, that you have standby help. Again, how many people should we have before entering? 2. Now we can have a team of 3. I like that. We have the attendant, we have the entrant, and then we have another personnel. So when you're looking at the team, a team of 3, at least 2 people outside, right? We want to test the atmosphere for gases. You're going to test for oxygen first, because the number one cause of death in a confined space is the lack of oxygen. If there's no oxygen in there, I need to put on some additional oxygen, right? So test for oxygen first. Then I'm going to test for what? Which gas? Combustible gases. I heard methane, very good. Anything that's explosive, combustible. And then I will test for toxic, because 9 times out of 10 when you're looking at, I heard hydrogen sulfide was one of the ones. Again, those, it may be toxic before explosive, but methane's going to get us before that toxic gas. So oxygen, combustible, and then we're going to test for the toxic gases. So you gave me oxygen, you told me methane was combustible, and I guess hydrogen sulfide is the toxic one. What's another gas that can be present that we don't want to? Carbon monoxide, carbon dioxide, very good. They're not combustible, but they are a fixant. You can die. Any other gases? Chlorine can be there, hopefully not that big, but chlorine is something that is very, very, very dangerous. Huh? It settles, so it's heavier than air. Now you just introduced a whole nother line of questioning. Chlorine, he said, was heavier than air, 2.5 times heavier. Methane is lighter, so what does that tell you we need to do? Is to test stratified layers. Got to make sure you're testing the stratified layers. And then provide ventilation while you are in there. Where, that should be where, W-E-A-R. You know, spell check is wonderful. But you got to make sure you have the right word when you're spell checking. Wear PPE. What's PPE? Personal protective equipment. So what type of PPE do I need when going into a confined space? Okay, respirators, self-contained breathing apparatus. What else? Harnesses. Very good. If the descent in there is greater than 5 feet, not only do I need a harness or a lifeline, but I have to have what? A mechanical method of retrieval. That's an EPA requirement there, or an OSHA. Mm-hmm.
If we're entering a potable water tank, under what conditions might we even think that there's methane or a combustible gas? I mean, normally the process does not produce methane, combustible gases, or likewise.
Okay, that's a good question. Dave, I got an aquifer.
You've got an aquifer?
I have an aquifer because that's what's supplying my ground storage tank. What minerals and gases are in that aquifer or in the soil or in the rock? Because when we're dealing with groundwater, it can be very, very high in mineral and gases as opposed to surface water. So it just depends on the strata of what we're dealing with and how we're, retrieving it from the ground. I can very much well have all of those things.
Or if you're running any equipment near there?
Yeah, equipment, the breakdown,
If there's any gas
carbon.
in the area?
Yeah. So there's always that possibility that they can be present. Yeah. You want to add something?
I was just thinking running a diesel generator right next to you, pulling it onto the tank. Or anything you introduce to the tank for maintenance.
Yeah.
You come in there, you're fixing, a bunch of leaks and stuff. And, oh, I don't need this, it's hot. Yeah.
Possibility there. So always a possibility. And I won't go into the fracking.
Oh.
But if you ever get a chance to watch Gas Leak 1 and 2, it was on cable. That will blow your mind. Gas Leak.
Gas leak?
Yeah, there was a 1 and there was a 2, where again, because of other activity, it's really contaminating quite a few aquifers, especially shallow wells. And literally, one guy on the last one, he had a water hose and a flame. Yeah.
Yeah, they
So
were
it's
doing
only
that
a
in
possibility.
Pennsylvania, turning their spigots on and lights.
Yeah, So possibility of gases, yes. That's the reason why from time to time, even in Houston, we would get calls with the water smelling like sulfur or rotten eggs, hydrogen sulfide. Even stagnant water, dead end, you can have the buildup of those gases there. Yes, sir.
I was gonna say, underneath the paint layer, you get a blister. We had one guy, I was working Mojave Generating Station, tunnels for the condensers, and just a maintenance crew in there, we blisters formed on the side of the tunnel. Workers, poked it, it's there, boom. It was full of liquid, and it burned his face.
Yeah. So make sure you have the proper PPE. It is considered a confined space. If you're going to go diving in a tank, again, you should be properly disinfected as far as your suits and things that you're going to wear. Okay. Entry team should be provided with training from OSHA. All right, disinfection. Before we can put it into service, you need to make sure that you are disinfecting the tank. There are several different methods for disinfecting the tank. And I don't know if it's in this particular module or the next module, disinfection, that we go through these in details. I think in this one it just tells you need to make sure that you're disinfecting prior to entering. That's pretty much on 17.7 is essentially what it's saying. Okay, at the bottom, should be disinfecting after maintenance. But when we get into the next module, well, even on 17.5, they give you some methods of, but this is mainly for lines. But when we talk about disinfection, I think module 16 will actually go through the process of how to properly disinfect. One method would be to, again, to maintain a residual of at least 50 parts per million, or fill the tank half or spray it with 200 milligrams per liter and let it sit for a length of time for proper disinfection. After you've disinfected the tank, you then want to pull the microbiological analysis or the back samples. If they come back negative, you can put that tank into service. If they do not come back negative, you have to go through the process of disinfection again until you get at least 2 consecutive samples that are negative prior to putting it in service. All right, and that concludes the part on storage. Are there any questions or comments or additional or something that you want the rest of the group to know that we didn't point out? Yes, sir. Kevin?
Recoating the painting, how often should that normally need to be done?
Need to be done, again, that's why we suggest the annual inspection, because that will dictate how often I'm going to see the peeling, I'm going to see the parts that are thinning out and things, or flaking. So it's going to be as necessary, but with the annual inspection, should catch it.
Throw this out, maybe get a response.
Okay.
If you're doing it every 10 years, you should be treating your water for corrosiveness? Is that too frequent, or does that sound about normal?
As far as painting every 10 years?
Sandblast and repaint,
Okay.
epoxy.
Okay, class, did you hear that? I'm going to throw it out to the class.
10 years sound normal for repaint?
Does 10 years sound normal for repaint?
Depends on how well it was done initially. Normally the top part where the oxygen is and the rafters, that's where you'll get your corrosion.
Yeah, right.
And normally when you build a tank, you fill it full of water, and then about 6 months down the road, you should go in and go back and re-sandblast anything that's shown up any rust.
That's good.
It's called holidays. And if you see holidays at about the 6-month stage, you need to go in there, blast the rust off, and recoat it. Then your tank might last 10 years. But if the holidays aren't repaired initially, you need to get, you'll get less.
So 10 years sounds like a pretty good lifespan out of that coating.
Yeah, it should be.
Yeah, okay.
They always went in and did at our 10-year, they did a paint thickness test.
Mm-hmm.
On the tank, you see.
Right. And that's where I was, the thinness, yeah. Or thickness, you all put it. That's what they're looking for. He said every 10 years. Anybody else? Any experience? Yes.
So recently done, and a lot of people will try to attempt to do that themselves. And yet, if you don't get the coating on, if you don't get the correct sanding, get it down, the right thickness,
Evenness.
that 10 years is out the window. You'd be lucky if you get 3. Also, you know, depending upon the pH, the coacidity of the water, so forth. And shopping around in Arizona, I didn't come up with too many. Like for a 100-matic pressure tank, 5,000 gallon, it costs just as much for a new one as it would to recoat it.
Wow.
So somebody knows
Wow.
of a good, reputable.
There's another problem, if you only have one tank and you need to recoat it, what are you gonna do? You have to get somebody to come in and with a temporary tank and
Yeah.
repipe everything. It kind of boils down to economics too.
Always.
Setting up a temporary tank for keeping the system going, so it can be pretty involved. I've done it before, and it's a real pain.
So anybody want to throw out the people they use, that you have real good rapport?
We use Ames Industrial. They're out of, yeah, you've heard of them.
And be careful of people that say, oh, I can do it.
Show me the paper.
Language keeping somebody
Yeah,
just saying, get out of here.
yeah.
They always gotta listen to their customers, and we check with the customers that they work for.
Yeah.
That's what we always do.
Okay.
Yeah, and it's not even
good point.
sanding, it's usually sandblasting.
Right.
White metal.
Sandblast.
Yeah.
Yeah.
And making sure your compressed air supply doesn't have water or oil in it.
No-
That's the big thing.
Yeah, it's not as simple.
Right, and ultimately, who's responsible? Although they may be saying that they can do all of this and produce this, ultimately, absolutely. So you have to keep that in mind too, and make sure that you're keeping your ducks in a row and falling behind with the right type of oversight.
Well, like you said, when it comes down to economics, when you have a boss, you know, the owner that says, well, I want you to use this person, but then not the one who's going out there inspecting it. And say, no, it's not here. It's not coming back.
And when you can show them that bottom line, hopefully the boss will say, okay, brother-in-law, not this job. Okay, good. All right, our next item that's on the agenda is the actual distribution system itself, and that starts on page 17-8. Now, we know there are a lot of different things that make up the distribution system. It's not just the storage, but we have pipes, we have lines, service lines, we have pumps, we have motors, we have booster stations, we have meters. All of these are very viable components of the distribution system in a whole. Valves, hydrants, these are other entities, and we'll actually go through each one of these separately. Now, regardless of what you have in your distribution system, again, they always refer back to meeting standards. What do they mean by standards? AWWA, EPA, as well as a lot of the different states, rely on American Water Works as far as producing the standards, the specs, because number one, they have a laboratory, they've tested all this stuff. And so why reinvent the wheel? So you want to make sure that they're meeting those standards. There are some critical safeguards. Who remember what the critical safeguards were of maintaining a distribution system? Having a residual. Now, is it a requirement in Arizona, that's where I am, for you to have a residual at the farthest part of your distribution system? Yes, what is it? 0.2? I see some people then, I hear 0.4. The minimum is what? And when you say 0.2, it's 0.2 free, or free. If you're looking at total or combined, then that number changes. Okay, so you need to know what the minimum is in the farthest reach, not the entry, but that last house out there on the last end there. So that's one, having a residual. That's one critical safeguard. What's another critical safeguard? Maintaining adequate pressure. And remember, adequate pressure, that first number that you all remember is 25. Never in any circumstance, even in emergency condition, should it drop below 20 psi. Very good. What's another critical safeguard? Huh? Oh, he said cross connection control. Now that's another word for me. What's a cross connection? Okay, I had positive contamination, backflow prevention. Okay, so a cross connection is a physical connection between a potable water source and one that's treated to a lesser degree, one that may contain a contaminating substance, or one that I just don't know what's in it. So when I have that physical connection, and I got some blank looks, so give me an example of a excellent. A hose left in an irrigation ditch. That's a possible cross connection. A hole, you mean I can't fill my swimming pool up with my hose?
You can, but you better leave a little air there.
Gotta leave an air gap. You just introduced something else. Cool, hold that. Very good. What was that? A private well, when you're tied into the public well also, or public water, absolutely cross connection possibility. So now that we know, and we're not saying that that private well has a contaminating substance, but it may be treated to a lesser degree or not at all. It may not have any protection whatsoever. Yeah. Yes. Absolutely. So now you have examples of cross connection. Or let's say that water tank that you carry around when you're doing repair to flood the area, and you connect it to the hydrant, and there's no air gap because your hose, cross connection. So, critical safeguard, as Alex pointed out, you need cross connection control. Lisa told me a cross connection control would be an air gap, which now we're looking at physical space. If I can provide physical space, now what's the criteria for that physical space? 2 pipe diameters, not less than 1 inch. If you do 2 inch, that's great. That's above and beyond. But the minimum is 1. So at least 2 pipe diameters, not less than 1 inch. Okay? That's good. I think I heard another cross connection control somewhere in here. Okay, what was that again? An RP. What's an RP? I didn't want you to do it. Okay, what is it? When you say check valve, now how about 2 check valves plus a reduced pressure zone? Yes, excellent. Any type of approved backflow prevention device. Could be an atmospheric pressure breaker. Okay, so any of those are approved. The deal with the ones that are approved, you got to be able to go in and check them, inspect them, and if they're for health hazard, on an annual basis. Okay, excellent. So those are some of the critical safeguards of the distribution system. Again, greater than 20 psi is required. We use in Texas 35 for normal distribution pressure. You use 25. The key is that 20 there. All right, pipe material. What type of material we have out there in the system? Ductile iron, cast iron, steel, concrete. What's the most widely used pipe installed as of today? PVC. Okay, cool. High density polyethylene can also be used. All right, pipe joints. A lot of different ways you can connect the pipes. We have mechanical joints. You all use those. We have the push-ons. We have the threaded. Bell and spigot. Any of you all still do bell and spigot? True bell and spigot? With the lead?
The lid
Lock and key, yeah, lead.
on the ductile iron?
Yeah. Still do, yeah. Repair. Flange. Cool. Like that with millions of bolts around. Excellent. So again, based on the pipe, based on the application, based on whether or not it's underground, above ground, in concrete or not, you will decide what's the best joint for that particular pipe. Maximum lead content, as far as your fitting and solder and flux, or solder and flux, some people like to say, 8%, no more than 8%, okay? 2% in your flux and solder. That changes as of January, so what are you all going to do? Do you know the new requirements as of January 2014? What lead content? Huh? 0. They give you a little. They don't take it all the way to 0, but 0.25, that's so close to 0, might as well be 0. So have you started thinking about what you're going to do? And what about all of that inventory? What about all that inventory? What are they suggesting you all do with all the inventory? Scrap it. So that's something, that's a serious thing. You don't have much time. What month is this? Any of you all rushing out there to put it in the ground before January 2014? But that's something you need to start looking at, because it is coming down the pipe. It's here, okay, that you have to address it. What was that? I didn't hear what Bernard said, or was it Jason? Oh, it was Kai. Sell it. If you sell it, make sure you don't get caught selling. True story, in Houston, we had a group of repair people that was taking what they were taking out of the ground. It's illegal, or at least in Houston it was, to take it and to sell it. They end up losing their job because of it. So know what your policy of your city or company is before you do something like that. They actually showed them on camera, and I'm like, oh my goodness, how embarrassing. Even the stuff they take out of the ground. So be familiar with that. Okay, other requirements. Your mains should be adequately sized to carry sufficient volume at adequate pressure. How do we determine what size lines we're putting in? Capacity? Demand, very good. I'm going back to demand. Super. So how much am I going to allow per person when I don't actually have flow? If I have actual flow data or usage, that's great. But if I don't have that, then there is a number that design engineers use per person per day. Wow, y'all use that much water here.
It depends on the community, because Las Vegas uses 450 per person
Wow, really?
on average.
Okay. Okay, let me rephrase that. What's the minimum? Because you,
We're talking engineers.
what's the minimum? Okay. All right, we're all over. How about 130? When you look at the fire insurance, they use 130. 130 gallons per person per day. 130. That's 130 is a lot less than 400, what they're telling me. And they're in drought in Nevada. I don't know, how do they get away with that? All right, you want to make sure the material that you're using is durable. We talked about corrosion. Corrosion can be a major part of your water lines also. So make sure that it can withstand, let's say, the external force that's placed on that pipe, as well as the internal pressure. When we're talking external forces, where am I laying this pipe? What type of buildings will be on this pipe? It needs to be able to withstand that. What type of internal pressure are we talking about? We said it must be able to maintain greater than 20 psi, but if you send water to me at 25 psi, you're going to get a call. So what type of pressure are we normally sending to our residents? 60 pounds at least or more. So we need, again, our rating of the pipe should be at least 150 psi. In some places they want better than that. So again, they need to be, our material need to be durable. The material use should not affect or change the quality of the water or the characteristics of the water. So, pipe characteristics, we're looking at diameter, and again, we've already said diameter. We're going to go back to what we determine significant volume is to determine the diameter, and the other things that we're going to look at materials. It's going to be based on, again, the weight of what goes on that pipe. It's going to also, the soil condition that we're laying that pipe will also help us to determine what's best. So, different types of pipe based on demands, peak flow, future, let's say expansion, fire flow, again, minimum from greater than one source is 500 gallons per minute to a maximum of 12,000 gallons per minute to provide adequate diameter for that fire flow. Daily pumping logs should show daily water demands. So when you have actual data, excellent source to use. If not, we're going to use 130 gallons per person. Now, published data that's out there also you can look at is look at the number of connections time P will give you a population. Maximum demand, we're looking at maximum daily demands time 2.4 to get that. Peak demands is time 1.25 peak hours. So the peak demand flows, you go back to this formula here, and I know all of us love math. Well, the area is equal to Q divided by V. Q is the quantity of flow in cubic feet per second. V is the velocity. From area, we can now determine the diameter of the pipe because area is pi times, what is area? Pi times r squared, or you can use diameter squared in that case also. Times 0.07 instead of times pi 0.785. Yeah, so either of those. All right, whatever pipe material you use, again, it does not negate the fact it must be approved or meet certain standards. So we have ANSI, NSF. Who remembers which standard as far as NSF that they mentioned earlier? 61, very good. We've already said the lead band, no more than 8% in your pipe and fittings, and no more than 0.2 lead in your solder and flux. And again, 2014, that drops down to 0.25. All right, your pipe must be strong enough to withstand the crushing strength, that's that external force, as well as the burst, the internal pressure from the PSI, hydrostatic, as well as water hammer. We talked about water hammer earlier. And it must also be able to withstand impact or shock loads. You told me earlier the most common pipe used is PVC pipe, right? Take a mental picture of where your PVC pipe is. Where is it? Huh? Well, rephrase. Where's the PVC pipe you have not put in the ground yet? Huh? It's in the sunlight? What does sunlight do to PVC resins? How long does it stay on the yard before you put it in the ground? You see a problem with that? Another form of job security, huh? Another form of job security. Do you all have harsh winters here? Oh, sometimes. What does cold weather do to PVC? So you take it out on the job site and accidentally drop it. Now what has occurred? Problem? Yeah. So now that you know that sunlight and cold weather can be a problem, what are you going to do with your PVC pipe? Yeah. It should be covered or stored inside. Now everybody, this is totally off the beam path. Any of you all have watched the new show Crossing Lines? I think we have a celebrity in our midst. No one watched Crossing Lines. Who does he look like? And I don't even know the actor's name. You got to go back and watch Crossing Lines. I'm going to Google that. Gosh, he's a splitting image. He's incognito. He's not telling us who he is. One of the head honchos there. All right. And then with PVC, of course, PVC gives us the flexibility. Because what happens to earth movement? Does the earth move? And if I have a non-flexible pipe, what's going to happen? Okay, job security again. So we want to make sure we're choosing a pipe that is flexible. Now, the key is it cannot flex too much. Part of the testing of our plastic pipe is to make sure the deflection is not greater than 5%. So we got to pull that mandrel through there to make sure we don't get a greater than 5% deflection. But we want it to be flexible. Flex strength, we can have a beam break, we can have shear break. Again, if it's not evenly supported, this is poor here with it sitting there on top of that, because we want to make sure when we are laying pipe that we have bedding underneath the pipe to support the pipe the full length of the pipe. Shear breaks, again, shifting of the earth, soil, hot, cold weather, again, expansion, contraction that's occurring. Okay. Want to make sure that the pipe we choose have carrying capacity. Function of the pipe diameter, or the internal wall of the pipe roughness. We're looking at the C factor, which refers back to the smoothness of the pipe. The higher the C factor, the smoother the water flow. The lower the C factor, now we have friction that's being created. And when you look at the different types of material, PVC probably has the highest C factor. PVC 150, asbestos cement 140. How many of you all are still putting that pipe in the ground? Very good on that, no answer there. So the ones that still have it, did you replace it all or line it? Probably not. How are you repairing it? Huh? You are abandoning it. That's a good job to be abandoning it. Okay, who's up here vibrating on us? All right, but when I repair it, that's what I actually put it on vibrate, but that one. When I repair it, make sure that you have the proper respirator. Make sure you keep it wet because of the fibers, the dust there. Cast iron unlined has a C factor of 100, lined 130, concrete cylinder 140 there. So we want to, again, choose pipe based on the C factor. Coefficient of roughness there. Excellent. Choose pipe based on durability. How good is that pipe to resist corrosion? Chemical deposit. Any of you all have a problem with tuberculation in your pipes? Tell the truth, yeah. How often are you cleaning those pipes on the water side? Huh? Not very often. So if you have some build up, you could start out with an 8-inch pipe, and over the years it can be reduced probably to a 4 or less diameter because of those chemical deposits there. And that's one thing, again, the suggestion is that we routine do some maintenance as far as pigging, cleaning water lines also. When we don't do that, we can end up back in the corrosion. Corrosion could be galvanic, electrolytic, as well as chemical, and now we have to deal with the corrosion with the breaks in the pipe because of that, or holes in pipes. Here we have scaling that has occurred. Scaling is a little different than tuberculation. Scaling is when you have an even deposit, but what started out to be a nice diameter, you can see the reduction of capacity there because of that. And these are all mineral deposit. So I heard someone was saying earlier, you have a lot of lime up in this area. You could have that build up inside your pipe where it's doing that. Tuberculation is where we have nodules built up, and this one here is really bad. Usually you can see through it. But you have the barnacles and nodules. Again, one of the ways that we're going to use as an operator process tool is to utilize the Baylis curve or the Langmuir index to determine whether or not we have corrosive or scale forming water. All right, installation of that pipe. Some of the things that will probably come into play, probably the best thing when it's already lined and we're just repairing, 9 times out of 10, we don't want to dig back down in there and replace that pipe. And so we're going to talk about ways that we can correct without doing that. But initially, we're going to choose pipe based on installation. In other words, a concrete pipe may weigh a whole lot, heck of a lot more than a PVC pipe, right? So now I need more people to install it. And so that will determine what I'm going to choose as my pipe material. The joint lengths that are available is another thing that will help me to determine which is the best type of pipe. We talked about joint types earlier. The mechanical joint is your most common, but we do have push-on O-rings. We have adaptations of the bell and spigots that are still be using. And the last, one of the last things we're going to choose the pipe is based on availability and cost. How readily can we get my fittings and things like that, especially if it's versus in the states, outside of the states, and the cost does play a factor. All right, now that we have the pipe, we're about to install it. There are some rules and regulations because not only do we have water pipes underground, we also have wastewater pipes. And so there are some standards that are out there as far as the separation between water and wastewater lines. What is the separation distance for water and wastewater? Huh? 6 feet? 2 and 6. Minimum of 2. Excuse me there. And I heard 10. 6 inches. He's like just throw a number out there. 6 inches. Huh? Yes, it will be a state requirement there. But there are, again, recommendation for a standard separation. 30 to 60 inches. Think feet. 9 feet in all directions. 9 feet in all directions. 9 feet in all directions. Okay, that's a good argument. He said there's because of growth, because of expansions, there's no way we can achieve that. So 9 feet is the standard, but guess what? There are exceptions to the rule. A 9 feet separation in all directions, there are exceptions. You find that on page, I'm not just spewing, 1711. Amanda's like she's keeping me straight. Very good. Thank you, Amanda. Okay. Now, when you can achieve that, you have to make sure, again, you look at your state rules because you can have them as close as 2 feet, 4 feet separation, but your water line must be encased and enclosed. It must follow at a certain angle. So you have to know the exceptions to the rule. But the standard is there. Okay, 9 feet in all directions. Which is on top, water or wastewater? Water, why?
Flows downhill.
Yeah, wastewater's gravity, it's going to flow down. They should be installed in separate trenches. Separate trenches, right? Cool. All right. Cover material. Now, your trenches for water installation should be as narrow as possible. Are we still going back there, Noel? Okay. Narrow as possible, just wide enough for the person to get in there and to do the work. Why? Because as we widen that trench out, you also increase the loading on that pipe. Okay? And you don't want to do that. So what we look at as a rule of thumb is 1 foot, 12 inches, wider than the diameter of that pipe. Okay, 1 foot. But try to keep it as narrow as possible. How much cover am I going to put on top of that pipe? Rule of thumb. Can I add a little more? Can I double that? Minimum of 24 inches. And again, if you're in an area where there's frosting, you want to go below that. In Texas, rule of thumb, we're doing 30 to 60. So you need to look at your frost lines also as to how much cover material that will go on. But a minimum of 24. All right, so those are your distribution lines. Now, service lines. What's a service line? We talked about the main. Okay, these are the lines that are going to our customers, right? Will they be made out of the same material as my main line? Not necessarily, because now we're talking anything. There's one main line in Houston that's a 96 inch. That's a pretty big main, huh? Yeah, we even have 8 inches, so various size 6 inches. But am I going to put a 6 inch to a residential home? No, why? They don't need that much water. So typically for service line, what size tubing, piping? 3/4, 5/8, 1 inch. Some of your larger homes that are very plush may want a 2 inch that they may negotiate with the city. But the purpose of service lines, as you told me, to transport the water from the main to the customer to the home. Parts could be a tapping saddle. You may not have to do that. You may can just put it right in on itself. We have the corporation stop, we have the curb stop or the meter stop. What's the difference between the corporation stop and the meter or curb stops? They are valves, I'll give you that much. Okay, one's on the main and one's where? Okay, very good. Who's responsible for from the main to the meter? Okay, and from the meter to the home? Homeowner, super. All right, single family service, we're looking at anywhere from a 3/4 to a 1 inch flexible tubing. Copper can be used, PVC, polybutylene, high density polyethylene, and this one is widely being used now. How many of you all still utilizing copper? Again, it was one that was widely used, and no problem with that whatsoever. But one of the things we have to be concerned with the copper piping now is what? The leaching out based on the lead and copper rule. Now, on that lead and copper rule, remember they're doing the testing from the 3 tiers to determine whether or not your copper, your 90th percentile is greater than 1.3 for copper. So it could be an issue for some. But typically that's the type of material we're going to use for service lines. Lead service lines are rare today because of that 91 rule, lead and copper. Replacement was put in place where you had to show you were removing at least 7% of your lead service line. We know lead to be very toxic, dissolves in corrosive water. In other words, as we're sleeping at night, lead and copper can be leaching out into our water. So when you get up the first thing in the morning and take that first squig, it could be laden with lead and copper that exceed the MCLs. So the MCL, or the action level for lead, was 0.015. For copper, it was 1.3 parts per million, or a milligram per liter. And again, because of the lead and copper rule, you have to go through the rounds of monitoring every 6 months, yada, 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 yada. Also, that last bullet was you had to replace your lead service line and show you were replacing so much every year. Copper service lines are approved. Copper is an essential nutrient that may dissolve in corrosive water. Again, the action level, 1.3 parts per million or milligrams per liter. If found in excess, water treatment, public education is required. What do we mean by public education? Tell the homeowners, let the water run until there's a temperature change. When you know there's a temperature change has occurred, you're getting water from the main and not the water in the house plumbing that's been laden the 6 to 18 hours. And so you're good to go. Oh, okay. And again, the periodic sampling was based on your initial round of sampling. If you had, again, an exceedance of the action level, then you had to increase the frequency of monitoring. If you did not exceed, you're on reduced monitoring. And a lot of people are on reduced monitoring now for lead and copper. Now, for commercial and industrial service, they probably will need a line that's greater than a 1 inch. So in these cases, it can be the same type of material as far as pipe as your main lines, and it can be, again, 2 inches or better. Small commercial, you're looking at multifamily, nursing homes, large commercial, hospital, manufacturing, chemical plants, or wood processing. So now we can go with the same material that we used on our main lines. All right, you want to make sure that when you are tapping in, and what do we mean by tapping in? Michael, you're the newbie.
Tapping in, isn't that when you access the water from another source?
Yeah, it's when I'm going to tie that service line into the main. You want to make sure that you don't put that tap on the top. Why? How many backhoe operators do we have? Any backhoe operators? Kai, very good. You have experience where you can feel? Yeah. You've ripped out a few? Yeah. Yeah, you want to make sure again, number one, also could be air up in that area. So to minimize air and to make sure that we're not putting too much pressure on our backhoe operators to feel, we're going to not put it on top of the mains, but put it off to the side. Snake it into the line. Again, the earth will move, so you'll have that movement. So staking it can help for expansion that will occur. Properly bedded and backfill. Bedding is what we're going to put underneath that pipe. Backfill is what goes on top. Both will support that pipe, the length of that pipe. Now, what type of material can I use for bedding? Okay, sand, cool. What else do you all use? I didn't hear. What? Cinders. That's a new word for me. What are cinders?
Volcanic rock.
Volcanic rock. Okay, I live in an area where we don't have that. That's a new word. Could you bring me some? Very good. Pea gravel, white rock, those are the kind of stuff, shale, the kind of stuff that we use in my part of the neck of the wood. Volcanic rock. Okay, cool. Notice what you said, all of that stuff has been inorganic, inert. So you want to make sure, again, no organic material. So your average everyday soil, not a good thing to use as bedding material. Not even a good thing for your initial backfill. Okay? So make sure, again, and we also said on the bedding, it should be the length of the pipe. Now, you have a picture in your book on page 17-14. Talks about bedding there. They give you the right, the wrong way of bedding. Notice what's right with the right way of bedding. That bedding is uniform the length of the pipe. All right, you want to make sure you're flushing your new service. In addition, if you look at AWWA's recommendation, they also tell you to do what? Disinfect. Cool. Check the chlorine residual again prior to putting it in service. So here you see the corporation stop. That's that valve that's connected to the main, as was pointed out earlier. And then you have the curb stop. What do you think about Home Depot, Lowe's selling the key to access that valve? Have you seen that? Yeah, they sell it now.
Just makes the homeowner pay for that valve when they break it.
Okay, so you see it as a plus. I'm leery of the homeowner getting out there messing with it. I thought maybe, especially somebody with just enough knowledge can be dangerous. Uh-huh.
We actually have a development going in, and we're actually requiring all the homeowners of the new houses to have a stop and waste on their side.
Okay,
Use the same key.
right. On their side is the key there.
Correct. Their side of the box.
I don't know. That one I,
Getting into the box.
huh?
It doesn't stop the homeowner from getting into the box and turning it off when you. They
I
can,
know.
just yesterday, 2 valves on their side, he wants to go into the box. I said, well, you've been paying for it.
Yeah, it doesn't. But any deterrent, in my opinion, is a good thing. See a hand? Oh, no? All right. I think I'm at the point now that I want to take a break. It is 11:50, and here's the deal. This is the break that goes into lunch.